Hello everyone. In our earlier two videos, we talked about trigonometric ratios. We had arrived at 6 trigonometric ratios. So, as soon as I say trigonometric ratios, what should come to your mind is right angles. And here in this video, we are going to see that given any one of the trigonometric ratios, let me write it as T ratios. T here stands for trigonometric. So, given any one of them, we have 6 of them, isn't it? Given any one of the 6 trigonometric ratios, we will arrive at the other ratios. Arriving at the others, the other trigonometric ratios. This is what we are planning to do in this video. So, let's assume that we were given sine theta, sine of theta, and it's mentioned that sine theta is 11 by 15. So, we will have to find the other trigonometric ratios. So, this is 90 degree, this is the 90 degree angle in this right triangle. Let's assume that this side, this angle is theta. So, now we will have to write down the sides with respect to theta. So, what is sine theta? We had seen that sine theta was a ratio of the opposite side by the hypotenuse. So, which is the opposite side here with respect to theta? This side is going to be our opposite side, because we will have to take theta as reference. So, since our theta is here, this is the opposite side, and this side which is close to theta is the adjacent side, and the hypotenuse is always the same because it is the largest side in any right angle triangle, the longest side with opposite which lays across the largest angle. The longest side which lays across the largest angle is the hypotenuse. So, given that this is our ratio now, we can assume that the opposite side is 11k. K is just multiple, because the ratio is 11 and 11 by 15. We will take opposite side as 11k and adjacent side as 15k. So, k is some constant, but the same constant. So, if you multiply 15 by k, you get the adjacent side. If you multiply 11 and k, we get the opposite side, as that is the ratio between them. So, now what can be the hypotenuse? I have made a mistake. This is opposite by hypotenuse, it's not opposite by adjacent. So, my hypotenuse is 15k. Hypotenuse is 15k, and we will have to find the third side, the adjacent side. So, let us apply the Pythagoras theorem. Being a right angle triangle, we have that the square of the hypotenuse, in according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse is equal to sum of the squares of the other two sides. So, in this case 15k the whole squared is equal to 11k the whole squared plus let us take this to be y, right, y squared. So, we can now easily find what y is. So, let me subtract 11k the whole square from both sides of the equation, and I am going to simplify also at the same time. So, we have 225k squared, 15 squared is 225, minus 121k squared is equal to y squared. But what we require here is y, isn't it? So, we will have to take a square root of y, but after a little simplification, let us subtract, because k squared can be taken as common. We can subtract 225 minus 121, this is equal to y squared. So, what is 225 minus 121? It is 5 minus 1, 4, 0, 104k squared is equal to y squared. So, let us take the square root of both sides in order to get our side y. So, this is y, right. So, 104 does not look like the square of any number. So, just breaking it into its prime factors, 2 5s 10 to 2s 4, 2 to 4 to 6, 12. I think we are done because 13 is a prime number. So I can maybe write 104 as 2 squared into 26. So the square root of 104 would be 2 root 26. Right? We can write the square root of 104 as 2 times square root of 26. So this y is equal to 2 root 26. Now it's easy for us to write the ratios, the other trigonometric ratios, because the adjacent side is now 2 root 26. Y is 2 root 26. But adjacent side is yk, isn't it? Because we've just found the ratios, so 2 root 26k. So let's proceed now. So sine theta is already given, 11 by 15. So now we'll have to recollect all those ratios. So what is cos theta? Cos theta is adjacent by hypotenuse. Let me recreate the figure here for better understanding. So this is the figure, and we had 11k here and we had 15k here, and we found the adjacent side to be 2 root 26k. So adjacent by hypotenuse is 2 root 26 by 15. So we found one ratio. Now what are the other ratios? Tan theta. Tan theta is sine by cos. So it's actually quite difficult to remember these ratios. So maybe if you know what is sine theta is opposite by hypotenuse, then you can arrive at the other ratios using the relationship between them. So tan theta is sine theta by cos theta. Or if you remember, sine theta is something which you have to remember. Sine theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse. So tan theta is opposite by adjacent. But the more sums we work out, we will remember the ratios as they are. We can skip this part. This part can be skipped. The more you work out sums, of course you will be made to work out by your schools. So this part can be skipped. So and you can just say opposite by adjacent. Tan theta is opposite by adjacent. So now since we have the ratios, the opposite is 11k and the adjacent is 2 root 26. So 11 by 2 root 26. Now there are 3 more ratios to be done, and all these 3 ratios are just the reciprocals of the first 3 ratios. So there are 2 ways to do it. Either recollect what they are, like secant theta, cosecant theta and cot theta. Secant theta can be, and the rest next is cosecant theta. This is 1 by sine theta, and cot theta. This is 1 by tan theta. So you can in fact write down the reciprocals from what you have found so far. Sine theta was already given to you. It's 11 by 15. Isn't it? Yeah, it's 11 by 15. We have done a lot. 11 by 15. So cosecant theta is 1 by sine theta. So we can write this as 15 by 11. And what about secant theta? It's cos theta, 1 by cos theta. So it's 15 by 2 root 26. And tan theta is 1 by cot theta. So cot theta is 1 by tan theta, whatever. They are reciprocal. So 2 root 26 by 11. We don't have to work out, or maybe even recollecting ratios part can be skipped. But there is one more easy way to remember these ratios. Let me discuss that in the next video. I hope you followed. Thank you.